Okay, problem number 9. We are looking for the coordinates of all underscored maximum and minimum points on the given interval. When you see something like that and you notice that we're working with a closed interval, we also need to include the endpoints. So this becomes an extreme value problem as opposed to just a relative min and max problem. So the first derivative is going to be 1 plus cosine of x. And we want to find out where that's 0. And that would be whenever cosine of x is negative 1, which is at x equals pi on the given interval. So since that is the only critical number on the interval, on the closed interval we're looking at, to find all max and min points, we only have to look at the endpoints, evaluate the original function at the endpoints and the critical number. Remember, we're looking for actual values in the function, so we have to go back to the original function here. And the original function is x plus sine x. Well, sine of negative pi over 2 is negative 1, so we end up with negative pi over 2 minus 1. Since sine of pi is 0, we end up with pi. And 3 pi over 2, sine of 3 pi over 2 is also negative 1, so we get 3 pi over 2 minus 1. And a little analysis would show that the minimum is at negative pi over 2 and the maximum is at pi. Sorry, because pi over 2 is about 1.5, so 3 pi over 2 is pi plus about 1.5, and 3 pi over 2 minus 1 would still be greater than pi. Now another way of looking at this is that 1 plus cosine of x, which is the derivative, the cosine of x has to oscillate between negative 1 and positive 1. So no matter how low cosine of x goes, at most the derivative can be 0, but it can never be negative. So this function is always positive or 0, which means that the original function, since the derivative is always greater than or equal to 0, then the original function has to always be increasing. It may be stationary at some point, as at x equals pi, but aside from that it's always increasing. So we know the function is always increasing, and that tells you then that the minimum point has to be the left-hand endpoint and the absolute maximum point has to be the right-hand endpoint. So that just kind of confirms what we were looking at there. The next thing we want to do for B is to find the coordinates of all points of inflection on the given interval. So since we're looking for points of inflection, we want to find the place where f prime prime of x, or the second derivative, changes sign. So the second derivative is simply negative sine of x. And negative sine of x is going to be 0 at either 0 or pi. So we'll make a sign chart for 0 and pi. And we need some test values that are easy to evaluate sine at. We'll use 11 pi over 6, pi over 2, and 7 pi over 6. At 11 pi over 6, sine of x is negative 1/2. So negative negative gives me positive. At pi over 2, sine of x is 0. No, sorry. Sine of x is 1, and negative 1 makes that interval negative. At 7 pi over 6, sine is negative 1/2. Negative times negative is positive. Since our points of inflection occur when the second derivative changes signs, we have a point of inflection at 0 and at pi. Okay, and then we're ready to go on to graph this. So the important information that we need from this are the 3 points that we have: negative pi over 2, comma negative pi over 2 minus 1, pi, comma pi, 3 pi over 2, comma 3 pi over 2 minus 1. So those are 3 points. We know that the function is increasing on the entire interval, and we know that it's concave up between negative pi over 2 and 0, concave down between 0 and pi, and concave up again between pi and 3 pi over 2. We'll continue in the next video.